We are still solving quadratic equations and inequalities. We just completed several examples of equations, and now we're going to move into solving quadratic inequalities. All right, so this one says to solve x squared minus 3x minus 10 less than 0 algebraically. All right, so if we solve this algebraically, we can first think of it like using the zero product property, and we can factor. So we're going to say x squared minus 3x minus 10, and we're going to temporarily use an equal sign, and then we'll come back to the inequality when we get our solutions here. So let's go ahead and factor this. So we got x times x, what multiplies to give us 10, adds to give us 3, so that's going to be 5 and 2. We need a -3, so the bigger number has to be negative. This one will be positive, and then we can use the zero product property to find our x-intercepts or our zeros. All right, so I'm going to add 5 and subtract 2. All right, so we've got +5 and -2 as our x-intercepts. So we're going to call these our critical values because originally, remember, we're working with an inequality, and we substituted an equal sign so that we could find these values. So these are going to be called critical values. All right, so we're going to use a number line to represent our solution set because we're looking for all x's that we can plug in here that make this quadratic inequality less than 0. All right, so if we have these critical values, we can say here's 0, here's -2, and here's 5. So because this is less than, we're going to use open circles because these points are not included. And then we're going to test points in each region. We have 3 regions. We have this here below -2. We have the part in between -2 and 5. And we have the region above 5. So we have 3 parts of this number line that we're going to test to see which area satisfies this inequality. And then that will be our solution set. All right, so let's start with a number less than 2. So let's plug in -3. All right, if we plug in -3, -3 squared is +9, -3 times -3 is +9, and then -10. All right, so that does not equal 0. So 8, let's see. I'm trying to do this in my head, so I've got 9, 18. 18 minus 10 is 8. So 8 less than 0. 8 is not less than 0. That's false. So that means this area is not part of the solution set. And then we need to check the part in the middle, -2 to 5. Well, 0 is in between those. That's an easy number to plug in. So let's plug in 0. 0 squared minus 3 times 0. All of that's going to be 0 minus 10. Is -10 less than 0? Yes, it is. So right now, this part works. This one did not. This one works. All right, let's choose a number bigger than 5. Let's choose 6. Let's plug in 6 to see if this works. 6 squared is 36. Minus 3 times 6, that's -18, and then -10. So that's going to equal 8. 8 is not less than 0. So this part does not work either. All right, so we can conclude that the middle section is going to be our solution set. So we're going to have open circles. We already determined that. And then we're going to shade this area. So all the numbers in between -2 and +5 will produce a number here less than 0. So that's how you would do a quadratic inequality algebraically. First, use it like it's an equation, solve it exactly the same way, and then test your region on the number line for your critical values, which come from the zeros of your quadratic inequality. Example 7 says, solve a quadratic inequality by graphing. So 2x squared minus x minus 4 greater than or equal to 0. So to save a little time, we're going to graph this using our graphing calculator. All right, so first thing I'm going to do is go to y equals. I'm going to type in 2x squared minus x minus 4 and hit graph. So what we're going to do is find the zeros, same as we did on example 6. This time we're just doing it using our calculator. So if you do second trace, you see 0 here, so I can do 2. And you see the cursor, I need to go to the left side. I'm going to find this 0 first. It's not exact, but we'll be able to get the 0 by using the calculator to isolate in this area. And then it says our 0 is about negative 1.19. So x is about negative 1.19. All right, let's see what the other 0 is. We're going to do the same thing. We're going to do second trace. We're going to do number 2 for 0. This time, we want to find the 0 on the right. Again, the 0 is where it crosses the x-axis. I'm going to hit enter on the right side of it. And I'm going to click enter again on the left side of it. And this one says about 1.69. So 1.69. So again, we can draw our number line and we can say negative 1.19 would be just past negative 1. And we can say here's 1, here's 2. So 1.67 is going to be somewhere in here. All right, so know where the numbers fall on the number line. And then for this one, we need greater than or equal to. So this time our points will be included. So we can say a solid circle and a solid circle here. And then we're going to check the 3 regions again just to kind of see. So negative 1.19, if we want to choose like negative 2, plug that in. We can do that. So if we choose negative 2, negative 2 squared would be 4. 4 times 2 is 8. 8 minus, or 8 plus 2 would be 10. 10 minus 4 is 6. Is 6 greater than or equal to 0? Yes. So this would be part of our solution. All right, plug 0 in. All I'm doing is substituting 0 for x. 0 minus 4 is negative 4 greater than or equal to 0. No, it's not. So this middle part is not going to be shaded. Let's check something above 1.69. All right. I don't know why I can't get that to look like a 9, but I'm going to try one more time. All right, that looks a little bit better. Now, let's try 2. 2 squared is 4. 4 times 2 is 8. 8 minus 2 is 6. 6 minus 4 is 2. 2 is greater than or equal to 0. So we can say that this part also includes numbers that are part of the solution set. So we can conclude that if we graph this on our number line, okay, then we can say that these were our 2 x-intercepts and the graph lies on or above the x-axis to the left of x equals negative 1.19 and to the right of x equals 1.69. So we can say that the solution is about, x less than or equal to negative 1.19. Not and. It's not going to be both solutions at the same time. It's going to be one or the other. So x greater than or equal to 1.69. All right, so if you have a number that is less than this or a number that is greater than this, that will be a number that falls within your solution set and will make this equation true, and that's what we want.